Guys, welcome back to my channel and I hope you are all doing extremely well. This is lecture 8 on linked list series. So far I covered 7 lectures and I highly recommend you to please start watching from lecture 1 till whatever I'm going to post. I strongly believe that at the end of this series you are going to be very strong in solving the linked list problems. Without further delay, let's get into today's lecture. Today we are going to solve one more problem, which is one of the curated problem from Geek for Geeks SD sheet on the linked list topic. The problem is all about we need to find the middle element of the linked list and we need to return its value. So let's get back to the diagram for a better understanding. If my list is something this 1, 2, 3, 4, 5, 5 next is null. And if we carefully observe, 3 is the middle one here, right? So we need to return 3 here in this case. What if we have even number of nodes? Here we are having total 5 and that is odd. So let's assume we have a list something like this 1, 2, 3, 4, 5, 6, 6 next is null. In this case, we can clearly observe there are two nodes which are middle. So in this case, we need to return the second one. That is nothing but 4. Okay, when there are even number of nodes, you need to return the second one. When there are odd number of nodes, you need to return exactly the middle one. So this is all about the problem statement. Let's see how we can solve this problem. So this problem can be solved in multiple ways as I saying every time. So every problem can be solved in different ways depending upon how a person is thinking. Okay. So these are my ways on this problem. So the first one is count the number of nodes. So assume if number of nodes are n. Okay. Then traverse till n by 2 and return n by 2 node value. Okay, let's try to understand this with an example. So if my list is something like this 1, 2, 3, 4 and 5 next is null. Okay, first is we need to count the number of nodes. So if you perform a count operation, we are going to get output as 5 here, right? Now we need to traverse till n by 2. So 5 divided by 2 gives you 2. Okay, you need to traverse till n by 2. Let's see, sorry. So currently I'm here. Okay, so assume I'm starting from 0, 1, 2, 3, 4. Okay, so is 0 less than 2? Yes, condition satisfies. Then I go forward. Then 1 is 1 less than 2? Yes, condition satisfies. Then I go forward. Is 2 less than 2? No. That means you need to return this node value 3. Okay. This is how it is working for odd number of nodes, right? So let's try to understand how it is going to work for the even number of nodes. So if my list is 1, 2, 3, 4, 5, 6 and 6 next is null. Okay. And as usual, length is going to be 6, n by 2 is going to be 6 by 2, that is nothing but 3. Okay. I need to traverse still less than 3. So let's start from here. So as usual 0, 1, 2, 3, 4, 5. Okay, first I will come. Is 0 less than 3? Yes. Then I will be here. Is 1 less than 3? Yes, condition satisfies. Then I will be here. Then is 2 less than 3? Yes, condition satisfies. Then I will be here. Is 3 less than 3? No, condition failed. Then you need to return wherever you are. So currently we are at this. So you need to return this 4. So this is all about the way one. Okay, so let's try to understand time and space complexities. So time complexity is going to be big O of n first to find the number of nodes, and big O of n by 2 is to find the exact middle node. So that is nothing but big O of n. Okay. The space complexity is going to be big O of 1 because we are not taking any additional list or else any additional data structure to solve this problem. Okay, this is all about the way one. So let's try to understand the second way. So second way is nothing but Floyd's detect cycle algorithm. So that is nothing but simply two pointers approach. Two pointers approach. So what we are going to do here is, so we are going to have two pointers. One is fast, one is slow. The fast always runs with a 2x speed, whereas slow always runs with x speed. So at the moment fast reaches to the destination, and we can assure slow is going to be exactly in the middle, right? So let's try to understand this with an example. 1, 2, 3, 4, 5, 5 next is null. Initially fast and slow are going to be at head, fast and slow, and every time I'm going to check is fast equal to null or its next is null. No, then I'm going to move my fast by two positions and I'm going to move my slow by one position. Then I check is my fast null and its next is null? No. Then I'm going to move my fast by two positions and my slow by one position. Is my fast null and its next is null? Yes, its next is null. So the condition fails. Then you need to return your slow value. So you are at 3, you are at the position where you are pointing to the third node. Just you need to return its value. So 3 is going to be returned. So this is for odd number of nodes. Let's try to understand the same for even number of nodes. 1, 2, 3, 4, 5, and 6. 6 next is going to be null. So let's try to apply the same rule here. Initially my fast is going to point here, my slow is going to point here, and I will check is my fast null and its next is null? No. Then I'm going to move my fast by two positions. Then I'm going to move my slow by one position. Is my fast null its next is null? No. Then I'm going to move my fast by two positions and I'm going to move my slow by one position. Is my fast null and its next is null? No. Then I'm going to move my fast by two positions, then my slow by one position. Is my fast is null? Yes, it is pointing to the null. So at this point, just return the slow value, as I said. So 4 is going to be returned. So this is the approach number 2. So what are the time and space complexities? The time and space complexity is going to be big of n, time complexity, and the space complexity is going to be big of 1. But this is a bit optimized compared to the previous one, right? Because we no need to perform the count operation here. That is an additional task for us, right? So let's try to understand the third way. Third way. So third way is all about like take a mid, initially it's point to head, and have a counter. Initially it is going to be 0. So whenever the counter is 1, then increment mid by one position. Okay, whenever C is nothing but counter, whenever C is equals to 1, then mid is equals to mid dot next. Okay, let's try to debug this with an example. So initially I'm going to have 1, 2, 3, 4, 5. Okay, 5 is next. What I'm going to do here is, so if this is my head, if this is my mid, okay, and initially my counter is going to be 0, okay, and we need to iterate till our head not equal to null, okay. So now let's try to understand this. Is my head null? No. Then what I need to do? The condition is my C mod 2 is equal to 1? That means odd. No, right? Because my C is currently 0. 0 mod 2 is 0. So 0 double equal to 1 is false. Then what I need to do? Then I'm going to change my head pointer and I'm going to increment my counter. Okay. Sorry. Now next to 1. Is head is null? No. Is 1 mod 2 is equals to 1? Yes. So at this point of time, just move your mid. Okay, your mid is going to be point here, and your count is going to be 2 here, and your head is going to point here. Now, is 2 more 2 is equals to 1? No. Then you need to increment your counter and you need to change the pointer of your head. Okay. Then is 3 more 2 equal to 1? Yes. At that moment, you need to change your mid pointer. Mid is going to point here, and your, one second. So your counter is going to be 4. Your head is going to be here. Okay. Is 4 more 2 equal to 1? No. Then your counter is going to be 5 and your head is going to be here. But here this condition failing, right? Head not equal to null. Till that position only we need to perform this all operations. But here it is, the condition is false. Then we need to return wherever we are. And that means wherever our mid is. So just return mid that val. Okay, something mid dot val or else data, anything, the data member of that list node class. So we need to return. So this is working for odd number of cases. I mean odd number of nodes, right? Let's try to understand for even number of nodes. So if my list is something like this, 1, 2, 3, 4, 5, 6, 6 next is null. And initially my counter is 0, my mid is here, my head also pointing to here. Okay, let's see. Is C mod 2 equal to 1? No, this condition is false. Then what I need to do? Change my header, increment my counter. Is 1 mod 2 equal to 1? Yes. At that position, change my mid, increment the counter, change the head. Is 2 mod equal to 2 is equals to 0? Sorry, 1? No, this condition is fail. So then increment counter, change head position. Is 3 mod 2 equal to 1? Yes. Then change mid, increment counter, change head pointer. Is 4 mod 2 equal to 1? No. Then increment counter, change header. Is 5 mod equal to 2? Yes. Change mid, increment counter, change head pointer. Now we can see head equal to null, then we terminate the loop. And at this point of time, we can see your mid is pointing to the exact node which we want as a result. And here we are going to return 4. So this is all about the third way. So what are the time and space complexities? The time complexity is going to be big O of n only still. The space complexity is going to be big O of 1. And auxiliary space. Okay, auxiliary space. Because we are taking an extra mid here. Okay. So that's all for these three approaches, and I hope you learned how to solve this problem. Let's code in one way. And here is I am, so I can choose any way. So we can go with the third way. Okay. So initially count is going to be 0 and node mid is going to be head. Okay, and we need to do what? While head not equal to null till this condition, what we need to do? We need to check if count mod 2 is equal to 1. If this is the case, then what we need to do? We need to do mid is equals to mid dot next. Okay. And if this is not the case, then we need to just increment the count. You can pre-increment also, not an issue. Then you need to change your head pointer. Head is equals to head dot next. So once you're done with this loop, at the end what you need to do? You need to just return mid dot data. That's it. Let's run. Okay, it compiled successfully. Let's submit. Great, it got submitted successfully. So that's all for this video. Thanks a lot. Please do subscribe to my channel, and I'm going to upload more valuable content on my channel. And I hope I'm not going to disappoint you in terms of learning. Thanks a lot once again. Bye bye.